Okay, thank you. Thank you for the opportunity, especially for the SL4 organizers. So, and today I'm talking about how do we make SL4 to become ISO um, 262 compliance, ASIL-D compliance. Basically, we are trying to get SL4 onto the automotive industries. So, and today I will talk about a few things. First thing is we introduce ourselves and then we talk about what is the ISO 26262 ASIL-D and MISRA, the relationship about it, and then we go through a little bit of the conflicts about how can we fix all the MISRA rules warnings and all kind of errors, and then we will elaborate what kind of problem between the MISRA and the proof side of SL4, the conflict between them, and then we show you some progress on the MISRA. So and let's start. And about Xcalibyte is a group of international guys, staff, and originally we do compiler for RISC. Now we specialize our compiler for RISC-V and only. Okay, and the team is from the old MIPS, SGI, and HP and Intel's Titanium compiler team, and we are OpenSys64 code base, and we're compatible with Clang and GCC and LLVM. Basically, we use Clang and GCC front end and EDG front end as well. And the backend, we now moving from our old backend to LVM as well. So we are compatible for the both the GCC side and the user and the Clang side for Linux. And for SL4, there's no problem whatsoever. Very simple. And we are specialized for RISC-V autonomous drivings and including robotics, and we are trying to help the deployment of SL4 kernel to the drives autonomous driving cars, the chipset like Horizon and any other chipset available for us to put SL4 on it. And also we have our own compiler-based static analysis for Xcalscan for helping anyone the application, even SL4 Excel, to become ISO 262 ASIL-D compliance. Okay, that's all about us. You can find out from our international website and about us and about our product and technology and solutions. So let's move on to the next page. Okay, so what is ASIL-D 26262, and what's the relationship between them and MISRA? So basically, now in the old days, all God knows all the German street standards. So ISO standard is one of them, and especially come down to autonomous drivings, the most harsh, I would say it's very serious and safety standards, ASIL-D. So ASIL, it comes from ABCD, and D is the most critical one, and it applies to from the hardware design to the software design, as I show you from the table, and it enforces a lot of principles for the software and design and implementations to satisfy this standard. So like the left-hand table, you have the one entry, one exit point, that kind of things. And then from the right-hand table, then they were saying that, okay, you have low capacity enforcement, like, how deep is your loop is, and that kind of thing. So this is the ISO standard. So, and since the supply chain from something like China, and most of the autonomous driving car manufacturer, they are building on top of two standards. One is the German standard, one is the Japanese standard, and by far is the most relaxed is the American standard. So what's the relationship between MISRAs? So MISRA, ISO 262 have a lot of standards, like a lot of rules. And then MISRA initially is not specialized for, it's not particularly for 26262, but most of the rules, actually, you will find out we compare by tables, and you will say, okay, they're quite similar. Basically, you can say MISRA can cover most of the ISO 262 rules. So, and in the industry, most likely, if a piece of software or firmware you pass MISRA C, and the software side you usually can pass the ISO 262, and that is the relationship between them. You can map them, and MISRA C rules is probably a very superset. Compared to 262. Of course, you want one of them, like just like on the top right table, you will see that the MISRA C rule doesn't cover the global variable stuff. So and just one of those, and the rest are all okay. You basically say MISRA, you comply, and 99% ISO 262 ASIL-D you comply. So inside the MISRA, you have a lot of guidelines. You have from guideline category, from mandatory to required advisory. So most of the mandatory required, and if you don't set mandatory required, sorry, you can't explain. You have to compile. And required one, you can usually if you can't satisfy them, you can write low reasons to saying that, okay, we see whether we can deviate from them. And advisory is that one is the most relaxed. Yet it's give you warning, and if you don't pass, you don't pass. It's good for your the software engineer to reflect them. And inside MISRA, there are two types. One is derivatives, those related for category implementation, compilation, build require, and some requirement traceabilities, and some code design issues. And of course, there's some overlaps between derivative and rules. And the rules you can see, there's literally around 22 rules. 22 category rules is over 200, between 200 and 300 sub rules. So that is all about MISRA. So let's take a look how ASIL4 itself, the L4V kernel, without any changes. And when we run the compliance tool, like anyone besides our own product, you will see a lot of rules is ASIL4 itself is not passed. So there's a lot of change we need to make it to it. And there are certain things that most expert at software engineering will saying that some of the rules are ridiculous, right? Or we say that all the MISRA stuff is usually for firmware and is not for OS like seL4 support dynamic stuff. So but at the end, you look at in the industry, and they're so stubborn. So we still had to try if you try to make it into the product and the market, and you make it have no choice, we had to fix a lot of nonsense mandatory or why mandatory and required rules errors. So you can see from this table, you can see thousands. So but not really scarce. Some of them are really easy to fix. Some later on we show you the progress. We take 2-3 months, we can rush it through, and most of them we clean them up very quick. And yeah, let's look at some of the major problem of between passing the MISRA compliance and it have the series in conflict with proofs like these rules. Okay, we run this and then we find this rule a lot of codes is breaking. The compliance tool complaining saying that sorry, your return is not the last statement of your functions, and you will see the habit of ASIL-4 code. Usually, it won't guarantee the return. It should be the end of the functions. It's about I think it's about the coding guideline or standard. Back in the old day when L4 started. So, but and all these things are anything related to control flow. We highly likely is going to be a proof conflict. So you either fix your code for MISRA, and then you ended up breaking the proofs. So it's a side chicken and chasing the tails. And we look at the other one as well. So this one is very funny. It's the same control flow. They say, sorry, you don't have brakes. And you can see the codings, the way in SL4 it's just no brakes. It returns most of them. So you ended up just like how are we going to fix these things? Are we going to fix it? And whether the certification organization accept that if we don't change it. So, and we still argue. We can argue about because all these control flow conflicts. Beside, you can see it's near 1,000 added up. So, I'm very lucky. I think for if for non-proof OS with this, and basically, and the compliance organization would not let you off if you just like that. But with the proof, in certain sense, it's saying that we can write a lot of reasoning using seL4 proof, saying that okay, in our proof, if you already prove that the return is cover your breaks, then the certified component, the certified organization will accept these reasons. So when you that is the easy bit of between MISRA and proof, and you can use reason deviations and give a lot of examples using seL4 basic proofs, and then make it up a long reasoning, and then the organization, certified organization will accept your reasons. So that's not too bad. Okay, here give you a very good example is another habit of I would say that I think I remember I report this to kernel. Kernel is, oh my god, we should never do that. So it's about the variable name, and the same as the declaration of the definition of a struct. So, but you look at this example, you say, oh my god, how are we going to fix it? So, and their conflict in MISRA, when you see two things, two definitions or a thing, either variable definition or struct definition, they confuse. They complain straight away. Because it's just a front end, compiler front end or tools front end complaints, you already exceeded. You're not supposed to do that. So, and there's two ways of fixing it. You either change your variables, or you either change your struct. So how are we going to pick it? So we're looking into the way that and require less work. So, but you will find that if you change the variable name or the struct name, one thing they affect is proof. So we ended up changing proof again. fixing proof again. But this time it's real fix, because if you don't change this, the compliance organization won't let you off. It just don't like it. It just you can't. You say they just say that you can't have two things with the same name. So and we find it now. You do a grab or you do a search, and you find the occurrence of the code, which one to fix it easier. So in this case, we find that changing the variable name, and with less proof impact and less occurrence of the changes. So then we decided to go by that way. If we change in the struct, you will find out we have 300 places to changes. So that's one of the effort is more on analyzing that the way making changes. It's not just rush to changes. And we change it is the less places change it and less impact. So the whole exercise of getting compliance is more on the process instead of the work itself. The effort of it is not analyzing it and choosing the best way. So, and this is an example, but we have millions of example. A really thick report is about 100, 200 pages. So we give it to our customers and we help them through get through the compliance. So telling them how to do it and the most effort estimation and doing that and so on and so forth. So you can see here's our progress. And you will see we start basically we're using a month, and we can significantly reduce the numbers and down to zero. Either you using the very high easy fixes, either when we're using derivations with a very good reasoning using the proof evidence. So you can see basically we have a branch. We haven't fully committed to open source yet, and will be soon after June and Ganok's team reviewing it. It's still a very big changes. It's still very big changes, I would say, and that including easy fix and proof fix and deviation reasoning to get the compliance. So and we particularly thank you to our partner, our strategic partner Horizons, and for their effort and partner with us to get the first prototype out nearly 90% of ISO ASIL-D compliant. So that is appreciation to them with their team and work with our team to get that.
Sorry to interrupt.
And yeah,
we have about 1 minute left of the time slot. So if you're close to wrapping up, we might have time for a few questions. But yeah, it's about
So I think
left.
this is my last page anyway. So and Xcalibyte can help you deploying ASIL-4 and faster and safer and better ASIL-4. So we have our own compliant tools. We are our very high performance compiler specialized for RISC-V. And if we lower SoC design, we optimize all the code for you, and even ASIL-4 code for you on that RISC-V. And then we have our static analysis product, Xcaliscan, and help you through all the course analysis and help you fixing the code and even the proofs. Thank you. That's all for us.
Thanks very much. We might have time for one very quick question. How long? You have 20 seconds.
Hi, thank you very much. I have some questions. So you now spend a lot of time, effort, and presumably since you're a company, also money on fixing syntactical issues to conform with the standard that was initially drafted in 1998. Do you think that, so did you contact MISRA and contact the people there and like talk to them about what verification means compared to what coding styles mean, and that a verified kernel might get an exemption from this coding style bullshit, if I may say? So
I tell you what, it's easier to convince the product organization, but it's very hard to convince anyone making the product in the industry. The automotive manufacturing and the supply chain is so stubborn. You need to convince 1,000 people.
Okay, that's
it's
fair.
so hard. Yeah, that is bad. But I think for the battery car coming, like we can do better job. And I will leave that job to kernel.
All right. Thanks very much.